In my previous lecture, we looked at basics of overriding. Today, we want to look at the rules that we must follow to achieve overriding. The first rule is that method signature must be same for both the parent and child methods. Now, let's look for an example where we have got animal as our parent class. Then we have dog as our child class. In both the parent and the child, we have got a method walk with the same signature. That is consists of the same name and the same arguments. In the parent, we defined the method walk, and in the child, we redefine. Now, the dog class redefines the walk method in the parent class in the way in which the dog wants it to be like. Because here, it's like walking animal in the animal class, then in the child class is the like walking dog, meaning to say the dog class redefines. Now, we provide an annotation here. This annotation instructs the compiler that you intend to override a method in the superclass. Being this method in the superclass, we intend to override this method in the superclass. If for some reasons the compiler detects that the method does not exist in one of the superclass, meaning to say possibly in one of the superclass, then it generates a compile error. That's the purpose of this annotation here at override. We are going to see it actually in the next lecture when we are going actually doing the actual practice where we are writing the code. Now, the other reason, second reason is the return type must be same. That one, it applies only from version 1 up to version 1.4. That is 1.0 up to 1.4 version. The return type must be the same. But from version 1.5 onwards, then there is covariant return type. Meaning to say, the base class method might have a broader return type as compared to the subclass. But this applies to objects and not to primitives. Like here we have got a class person with a method number as a return type. Let's just say public number get height. Here, then here again get height. This method is an overridden method. It is overridden by a class in student which extends person. We have the same method, but the return type now is different. This one is now a narrow one as compared to the parent class return type being a number. But also integer extends a number. There is a certain sort of relationship between this integer and a number. The same applies. We can also apply something like an object. Then here we are saying a string. A string is a subclass of this object class. But this one is more broader than the string return type. So this applies from 1.5 onwards. But for version 1 up to 1.4, the return type must be the same. Let's go on to the next rule. Parent private methods are not available in child class, hence not candidates for overriding. Meaning to say, when a method is private, it is not accessible to the subclass. Therefore, it cannot be overridden. Only public, default, or protected are accessible to the child. This one is only accessible within a class where it is defined. Parent private methods are available in a class in which they are defined, hence they are not candidates for overriding. We cannot override a private method. Final methods are also not overridden and cannot be redefined, meaning to say they cannot be redefined. Because when we are overriding a method, we are trying to redefine that method in a subclass. But a final method is a method that is final, that cannot be redefined or to change the way it was implemented. So it's not possible to redefine a final method. Method declared, another one is methods that are declared static cannot be overridden. When a class defines a method, one is static and the other one is not static. That static method cannot be overridden, because if we try to declare the same method in the child class, that is called method hiding. Let's look at an example like, let's take an example like this. Let's say we have got a class person here. Let's just say person. If this class person have got a static method, public static void show. Like this. Then another class now. Another class being a student. A student class. A student class. Why is too much errors here? Students class with again a public static. This one, another method here. These two methods, students extends person. This class here is not overriding this method in the person class. But these methods are hidden. This method cannot be accessed using student reference, but can be accessed using only the person reference. So we can't access the two. This is method hiding, not overriding. So let's take note. This is what? Method hiding, not overriding. Here. Going to the next row, constructors cannot be overridden because constructor and parent cannot be same as in child. What it simply means is the constructor of the parent is not the same as the constructor of the child. Because if we have something like a person, the constructor of this person is public, or it's just person. This is the constructor. Whereas this constructor for this one, this student is just a student. Meaning to say the two is different. Meaning the rule number one, which you say is that the returning type, the signature must be the same, now is being defeated here. The signature is no longer the same. Why? Because we have student here, and here we have got a person. So constructor cannot be overridden because constructor in parent cannot be same as the constructor in child. Parent-child constructor are different from each other. So there is no possibility of having overriding using constructors. Now, let's continue looking at we should always override abstract methods. Now here, abstract methods are methods that don't have body. Meaning to say it's just a method without body, which ends with a semicolon, like abstract method what? Method 1. Yeah. And ends with a semicolon. Let's just also bring the return type here. Void. Abstract void. Like this. This is an abstract method. Usually, an abstract method is found in an abstract class. When we define an abstract method, the class that contains that abstract method is supposed to be an abstract class. That's another rule, but it doesn't apply to what we are doing here, the rule of overriding. So we should always override abstract class. So who is going to provide the implementation to these abstract class? Meaning to say these are clear, it's clear that these are candidates for overriding. A class that is going to override, a class that is going to implement these, or a class that is going to extend an abstract class, which is a concrete class, is supposed to provide the complete implementation for this method. We have got an abstract class, an implementation class supposed to provide implementation class for this method. Now let's continue. Now, another rule is exception handling rules. 1. If superclass does not throw any checked exception, then subclass must throw checked exception. If superclass does not throw any checked exception, then subclass must not throw any checked exception. Meaning to say, if we have a class like super being a parent class, public void show throws exception. Let's say here, this method doesn't throw any exception. Then the child's subclass, public class, subclass extends superclass. This also must not throw any checked exception. But this subclass can throw unchecked exception, meaning to say it can throw runtime what? Exception. Can it throw runtime exception? Why? Because this runtime exception is not a checked exception. The rule applies only to checked exception. But if this throws a checked exception, it becomes an error. That's the rule number 1. Now let's go on to rule number 2. The overriding method should throw a checked exception narrower than the overridden method in the parent class. Meaning to say, if the overriding method here throws a checked exception, this is a checked exception, this must be narrower than the parent checked exception, being this exception is more broader than this overriding method checked exception. Meaning to say, we cannot say public void throws file not found exception here, because this is the overridden method. Means suppose not to have a narrow checked exception like this. This one won't work. This one gives an error because this exception is more broader. Is broader than the what? The overridden method is checked exception. It's supposed to be narrow, so this one won't compile. Supposed to throw what? A narrow checked exception. Now the last rule is the access modifier of the overridden method should be more restrictive than the overriding method. Meaning to say, when we are having a method like this parent class method show, it's supposed to have an access modifier like public here and public here. It's okay, it's fine. Then let's say here we are having protected here. The child overriding method is supposed to have either public or it's supposed to have a protected method. The access modifier here and here are the same, or it's less restrictive here on the overriding method than the overridden method. If we got here default, it's either here is also default here, though we are not supposed to specify here, but it's supposed to be public or protected or default if the parent overridden method is default. I think this diagram try to explain it a bit clearer. Here we are trying to say the public, if the parent access modifier method is public, the overriding method can be public. If it is protected, it can be protected or public. If it's default, it's either default, public, and protected. But if the modifier is private, let's say here is private, what will happen? This method is not accessible in this, so it's not possible to override this one. We cannot override here because it's only accessible here. It's more like we have another method that is different from the method in the parent class. Now here I was trying, this diagram just tried to show that how the covariant actually applies, where we can have the parent method return type is an object, and the overriding method return type can be a string buffer or covariant or object. Then number, double, integer or number or float for the child. But the covariant return type, I think I have highlighted it earlier on when I was talking about the covariant. It's supposed it's not applicable for primitives. In the next lecture, we are going to look at this in detail in code. Thank you very much. Thank you very much. Don't forget to subscribe.